Okay, let's see how we go on day 11. I almost said 10. Alright, cool. 3, 2, 1, go. It's encode again. Are you joking me? Alright, what am I doing this time? Okay. Use instructions to access the robot's camera. Provide 0 if the robot is over a black panel or 1 if the robot is over a white panel. Then the program will output 2 values. So okay, and so what's the dimensions? Is it an infinite grid? Okay, so I guess I'll take day 9's code and I'm just gonna put that in day part 1, and that is going to and I want to do pass int code from file, and I'm just going to put 0 here for now. And so the first step, and we've got our program, we've also got a grid, and that's in the form of a map of actually that's bool. I'm going to say it's a bool. And we've got our current xy, I guess. And so we're going to match map.try find xy with our grid with true, and so that means that we're going to do program write to input 1, false prog write to input 0. Yeah? And then we're going to do and then we're going to get 2 values, right? So one is let paint prog equal read from input, read from output, and let dir prog equal read from output, and we're going to say that new grid is equal to and that's our grid, and new x, y equal to if the, I guess I need a direction, right? If dir is equal to 0, then what happens to that? So if 0 means left, right? 0 means turn left 90 degrees. So that means that any x which was facing positive will be 0. So then it's going to be zero. Oh. It's dy. So that was 0, but the x was going positive, and we want y to go negative. So that's going to be negative dx, I think. Else, and that's going to be dy, negative dy dx, I think that's what we want. So, and then we get xy is equal to x plus dx, y plus dy, and we're going to step our program with our new grid at xy with dx dy, and our termination condition is if prog dot wait, when does it halt? I'm going to try see if it halts down here. And that's run until output. Yeah. And so if prog dot is halted, then we return the grid. Else, and I do that one more time down here. And let's step. So we've got our map.empty, it's an empty grid. And that should be some true, and that should be otherwise. And that's an L, and that's an L, and that's an L. And this is going to assume we're starting at 0, and we're facing up, so that's going to be 0, negative 1, I think. And what's wrong here? What do you mean it's a function cannot be applied? It's and then this is prog. And so let's just, I want to see what this outputs. So G is going to be, wait, what? Why is that like that? Programs, a program state grid, x, y, dx, dy. It's a step. What? This should output a grid. Two, 3, 7, 3? Ah, 90, okay. Okay, let me copy that again. And let map.toSec sec.map first, and so this is drs, and we want min x is equal to sec.map first, sec.min. This is max x max, and we want the same for y. This is a weird one again. And so I guess we want to do for y is equal to min y to max y, do for x equals min x to max x do. And so if match map.try find xy in the does in G with some true, then we want to print f %s hash. Otherwise, print f. We just need this, right? And that's a space, and then print fn. And this is just going to be an empty one. I'm an idiot. And so I guess. No, what's wrong? Int code. Okay, is it going to compile? What? What? Okay. Ah, right. I need to do come on. PCK RLP UK. Yay, there we go. Ah, that was good. He did it in 4 minutes and 52 seconds? That's insane. Okay. Well, I'm happy with that. Was it 90, 70? Cool beans.